All right. So, hello and welcome everyone. We are live right now. Welcome back to this amazing platform of Tutee Learning. Okay. So, I hope you are doing wonderful. So, today in this particular session, we are going to discuss some of the important questions from the topic of identity card. And especially, we are going to discuss the previous year JEE advanced questions from the chapter of identity card, right? So, if you recall, in the last class, we have been discussing with different types of questions, and also we saw that if you don't know how to plot or how to get the card, how can you plot the card? First of all, doing by the application of derivative approach, and once you are done with that particular approach, then you have to get to the area by the different definite integral, right? So that is all what we have learned in our previous classes, right? So if you haven't watch the previous lecture, my utmost request to all of you is basically go back to the channel, okay, and in the playlist you will find all the videos that has been taken so far on definite integral and identity curve, okay. So please check out the playlist on this particular channel, and then you can find out all those particular lectures that has been taken so far, right? So please watch those previous lectures before you start to watch this today's session, right? And I said that after this completion of the area under the curve, we're going to start with differential equations, right? So we will be starting with differential equation in the upcoming lecture, that is from tomorrow. But today we're going to finish the JEE Advanced previous year questions. Okay, so today our target is to finish the JEE Advanced previous year questions. Okay, so today we will be solving the JEE Advanced previous year question from the topic of area under the curve. Okay, from the topic of area under the curve. All right, so let's get started with this particular topic, and we will start to solve some questions. First of all, what I will do is that I will give you the question, and then I will ask you to solve it. Once you are done with your try, we will start to solve or see the exact solution of it, right? So let's get started. So let us start with the very simple question. So I'm starting with the all the single correct types of questions, okay, at first. So the question says that let R denotes set of all real number, okay. Let R denote set of all real number. Then you have to find the area of the region that is given as x comma y is belonging to R cross R, okay, R cross R, such that x is greater than 0, y is greater than 1 upon x, 5x minus 4y is greater than 1, and the last condition is given as 4x plus 4y is less than, sorry, is less than 17. So this is the entire condition of the question, okay. So this is the entire condition of the question. So you have to find the area of this particular region, which is given by the following inequality over here, okay. So can you try to solve this question? Can you just give it a try? Just give it a try. Please try to get to the solution. Find the area of Please try to get to the solution, or maybe think about it, okay, how can you proceed with the solution, so that I can help you out that this is the way you're going to proceed in actual examination, okay. Think about it. I'm going to tell you the solution next, okay. So please let me know your thoughts in the live chat, okay. If you're watching this lecture live, please let me know in the live chat. And also please share these videos among your friends, your juniors, as well as your relatives, whom you know that they are also preparing for JEE mains and advanced examination, because this particular channel aims towards free education for all. So on this YouTube we are coming live to promote this educational contents of free over YouTube. So you just need to have an internet connection to watch these particular sessions, okay. So please give your best and also support us in this particular journey. So please like all the video, as well as share these videos among your friends and all of other people as well, right? And if you like these particular videos and you want to study from us, you can always contact us for one-on-one tuition or online batches, because we also have our online live batches where you can get the privilege to study one-on-one from me. So for that, please contact the number that is given in the live chat, okay. Also that is also given in the description box. Okay, so please contact us on that particular number to get access to the live classes as well as mentorship, especially from the from me and my team as well, right? Also, you can see on this particular platform that we are not only discussing mathematics, we have been also coming live with chemistry, physics, and also the biology part is basically going on the other channel that is called as TUT Learning NEET. Okay, so please follow the all the three channels so that you get to get the best mix of all the knowledges. Okay, is this clear to all of you? I hope this is clear. I hope this part is clear to all of you, right? So please let me know in the live chat any solutions, any answers. Okay, so let's quickly see the solution for this particular problem. Okay, so let's quickly see the solution. So, so first of all, looking at this particular region, the first thing that I have to do over here is to plot the region, right? So let's try to plot the graph of this following function and try to find out that which is the common region that I have to find the area for, right? So if I first of all try to plot it, so let me draw the coordinate axis. So this is my x-axis and this is my y-axis, right? And if you look at the first curve that is x is greater than 0, so that is basically talking about the this particular above the x-axis, right? Above the x-axis. Sorry, x is greater than 0. Sorry, it's basically talking about this particular part. Okay, this particular part. Okay. Please don't confuse it. That is x is greater than 0 means 0 is over here. So x equal to 0 is this particular line that is y-axis and greater than 0 means this particular part of the y-axis. Okay, this particular part. Okay. So that is very simple. And if I try to plot the second curve, so that is y greater than 1 upon x. Okay. The second curve y is equal to 1 upon x is a rectangular hyperbola, which is something like this. It's something like this, right? It's something like this. And if you look, the particular region that we are interested in is y should be greater than 1 upon x. Okay. Y should be greater than 1 upon x. So if I take up any point, let us say I take this particular point, let us say some point, let us say this is 1 and this is 5. So let us say 5 comma 1. Yes, it is satisfying it, right? So therefore, you can see that the region which is bounded by this particular curve is basically this particular region, right? I hope this is clear. Now, if I draw the second curve that is a straight line that is 5x minus 4y is greater than 1 is basically a straight line and which I can draw easily by. So let me draw that particular straight line. So 5x minus 4y is greater than 1. So if I try to plot the first of all at x equal to 0, y is equal to minus of 1 upon 4, right? So this is something over here that is 0 comma minus of 1 upon 4, and at y is equal to 0, x is 1 upon 5, 1 upon 5. So the straight line is something like this. Okay, the straight line is something like this. And similarly, if I draw this particular straight line, it is going to be 4 upon 17 as both the x and y intercept, and something like this, and something like this over here, right? So this is the curve over there, right? Now, and one more thing to note over there is that okay, so ultimately, if you look at this second curve, this particular last curve or the inequality is basically talking about the inside region, right? Inside region, and similarly, this particular curve is talking about the region which is like this over here. So the intersection of all these three will give me the ultimate region that is basically this particular region. Okay, so I have to find the area of this particular region over here, right? So how will I do that? First of all, let me find all the point of intersection so that it is easy. So the straight lines are intersecting at point P, and if you try to solve this particular line and this particular line, you will find the point P can be simply given as so if you add it, you will get the point P, which is basically 2 comma 2 comma 9 upon 4. Okay, so point P can be given as 2 comma 9 upon 4, and let me draw S. perpendicular from this point P on the x-axis and this particular point, and also let us also find this particular point as well. So let's call this point A, this straight line and the curve that is 1 upon x. So if I put y is equal to 1 upon x and then I solve the quadratic, so the point A, the x-axis of the point A will come at 1 comma 0. Okay, so it is going to be equal to 1. And similarly for point, let's call this point B and let's call this point C. So this C point will come out as, the C point is basically x equal to 2, right? X equal to 2, and this is basically x equal to 1, right? And also let us find this particular point, that is this curve and this curve. Again, we solve the quadratic and we get to the solution of this x equals to 4. Okay, x equals to 4 is this point. So let us call this point as D. Okay, so we call all the points. Now we have to basically find out the required area, right? So how will we do the find out the area? Now, what I will do is that I will try to use as much as possible areas of the regular geometries, right? Like trapezium, like rectangle, square, like this, right? And I will try to use the integration as at least as possible. Okay. So I won't be using the integrals very much. What I will do, I will try to use the simple algebraic formulas that we know for the standard geometries, right? So if you look over here, this is particularly a trapezium, right? So this trapezium and this is another trapezium. So if I sum up all the area of this two trapezium and then subtract this particular area and then subtract this blue region and then I subtract the blue region, I will get the required yellow region area, right? So what I'm going to do over here is that it's very simple. So my required area, so my required area So my required area can be given as, so let me call as A, can be given as sum of these two trapezium, right? That is area of, so I am using TARP, that is short form for trapezium, that is A, B, C and P plus area of trapezium CD, P, sorry, we have to name some point over here. Let us call this E, CEDP. Okay, CEDP, CEDP, and then subtract this particular blue region area. Now, for the blue region area, it is easy that we can use it the simple integration, that is integration under this particular curve. Now, this particular curve is y is equal to 1 upon x. Now, we know the simple integral result for it. So, therefore, subtracting the area under the curve from x equals to 1 to x equal to 4 for the curve 1 upon x dx, right? So this will give me the required area of the given region, that is set in yellow. Okay, so the yellow region area is given by this particular way. Okay, so you can see over here that I'm trying to use as less as possible the use of integrals, right? Because when you know the area for the standard region, you don't have to perform the integral to make your results more cumbersome. So sometimes in mains examination, when your time is limited, when you have to solve more number of problems in order to get better rank or better score, then you have to use these kinds of smart adjustment. Okay, so as to get to the answer really quick. Okay, so therefore if I solve it, and you can also solve it by yourself, that is half times the area of the trapezium can be given as sum of the parallel sides. So this particular so this point A, I have to find this point A also properly. So this point A will be given out as uh, this is x equals to 1, right? And this line is basically this particular line. So x equals to 1, and it will also give y is equal to 1, right? It will also give y is equal to 1. So this is 1, and this particular is 9 upon 4. So therefore, the sum of the parallel side is 1 plus 9 upon 4 multiplied with the distance of the parallel side, that is basically 1. And then this particular trapezium, that is 2 half times again. The distance of the parallel side is given as 2. So 2 into multiplied with the sum of the parallel side. So this particular point at x equals to 4, this particular point becomes, so this is basically a point on this particular line. So I can put x equals to 4 over here, 16. So 16 minus 17. So this is going to give you 1 upon 4, right? This is going to give you 1 upon 4, because it's also lying on this y is equal to 1 upon x line, right? So x equal to 4, y will be 1 upon 4, right? So y are 1 upon 4, 1 upon 4, and this particular is 9 upon 4, right? So this is going to be 1 upon 4 plus 9 upon 4 minus the integration of 1 by x is basically natural log of x, and within the limit x equals to 1 to 4. So within the limit x equals to 1 to 4. Now if I substitute all the values over here, the required answer, that is the area of the yellow region, can be given as can be given as 33 upon 8 minus natural log 2 times of natural log 2. Okay. And then you can put the natural log of 2, the value of natural log of 2 to get to the final appropriate answer. Okay. Or approximate answer. Okay. So from this, but ultimately the answer was given in this particular form. So even if you have found out till this answer, you are going to get the full mark. So that was one of the option. Okay. So I hope this question is clear to all of you. Is this question clear to all of you? Please let me know in the live chat. Is this question clear to all of you? Tejas, hello. 19 upon 128. No, no, Tejas, that is not correct. 33 upon 8 minus 2 log 2. Is it clear to all of you? Tejas, check your calculation again. Maybe you did the wrong integration, or maybe if you're not even using this particular standard way of finding that, still you will going to get the correct result. Okay, please don't forget that you have to break the integral limits in the two different regions, because for one region it is like this particular area, and for the other region it is these two areas, right? So even if you try to find it by the integration approach, then don't forget that is curve 1 minus curve 2 for a given region, and then curve 1 minus curve 2 for another region. Okay, so break the limit appropriately to get to the final answer. Is that clear, Tejas? Is that clear? Is this question clear to all of you? Please let me know in the live chat. Is this question clear? Okay, so this was one of the previous year JEE advanced questions, okay, that came in the last year, 2025 only. Okay, so if you have checked out the paper of that, then you must have known that this was one of the question, okay, and it's the simplest question from the chapter of area under the curve, okay. Just you have to keep on doing the integration properly to get to the final answer, okay. All right, so let's get back to another curve, another question. And now I will be taking one very interesting problem that is basically that was asked in the previous year JEE Advance, okay, and it is basically question from the JEE Advance 2021, okay, and it was one of the numerical type question, okay. Just give me a second, I will show you the question. Yeah, so the question is very interesting. Okay, the question is very interesting. This was one of the JEE Advanced previous year question from 2021 paper, which was conducted by IIT Kharagpur. Okay, so it is saying that for any real number x, for any real number x, let let this bracket of x denotes the greatest integer function. Okay, so in IIT level question, they don't tell you greatest integer function because they might assume that you don't even know what is greatest integer function, so they will define you for you. Okay, so they will define it for you, and they said that let this particular bracket denotes the largest integer less than or equal to x. That basically means simply greatest integer of x. Okay, so please note the language. I am cutting off the language so as to save time. So that is basically said. They said that this bracket, this square bracket of x denotes the largest integer less than or equal to x. That basically simply means it's a greatest integer function. Okay. Then in the question it was asked the integral going from 0 to 10, integral going from 0 to 10 for the given function 10x upon x plus 1 and square root of that, and then ultimately putting a gradation of it. Okay, gradation of it. So you have to find out the value of 9 times of I. So you have to find out the value of 9 times of I. So that was one of the key question that has been asked in the previous JEE advanced problems, right? So looking at the problem, it might look very non-linear, and sometimes some these kinds of question actually is basically to is test your aptitude. Okay, so basically whether you are trained in a simple manner, that you are only trained to solve those questions, like the one example question is done and we change of little bit of parameters, you are able to solve the question in the JEE mains and advanced. So they are trying to check whether you are basically trained in that particular manner, or are you trained to adjust yourself to different sets of questions. So are you able to apply your brain or not? Okay, so this was one of the question over there. Okay, so generally good students actually try to think it in a very different way. Okay, but the most simplest approach that I can find is basically by simply plotting the graph. Okay, so because it's a gradation function, so the curve is going to be a constant function like that, a step function like that, right? But before I do that step function, I need to know that what are my proper bound of my given function within the given limits. Okay, so first of all, let's try to analyze that particular thing over here step by step. So first of all, if I analyze it step by step, what I observe is that the limit of x goes from 0 to 10. Okay, the limit of x goes from 0 to 10, right? Now I have to find or figure it out that within this particular limit, what is the largest and the minimum or maxima and the minima of this function that is present inside. Okay, what I'm going to do is that I'm going to first of all check the values, check the values that for what value of x am I getting this particular value equal to 1. Okay, similarly for what values of x this particular value is becoming equal to 3, like this and so onwards, right? Or if I'm taking under this so if I'm taking this particular param which is basically inside the square root, so I have to equate to the perfect square, that is 1 4 and something like that, so that whatever is coming out, the whatever for whatever values of x is there, the greatest integer of it will always give you the integer result, right? So I am trying to equate it to that particular x where it is basically giving you the integer result, because if I'm getting the integer result, all those values of x which is lying in between that will obviously get the same integer value. That is the basic advantage of having the greatest integer function, right? So if I try to solve it for equal to 1, I will get x equals to 1 upon 9. So what do you understand is that whenever x is going from 0 to 1 upon 9, this particular value is obviously the square root value of this is obviously less than 1, and therefore whatever is present, the greatest integer will always give you 0. Is this clear to all of you why I am doing it? A simple approach. Now, this is a very standard approach that we follow everywhere. So whenever we have a gradation of x, anything, we try to see that for what values of this particular function that is sitting inside the greatest integer is equals to some integer value, and from that we predict that given in that particular given range, it is basically a integer or not, right? I hope this approach is clear to all of you, right? So from here, and similarly, if I try to put 10x 10x divided by x plus 1 is equals to 4, right? That is basically when you have the square root of it, it will be equal to 2, right? So the integer 2. So if you put equal to 4 and if you solve for x, you will get x equals to 2 upon 3. You will get x equals to 2 upon 3. So what do you understand is that for the limit from x lying from 1 upon 9 to 2 upon 3, the whatever the gradation of it present, it will obviously give you the answer as 1. Will give you the answer as 1. Right. Similarly, the next bound will be 3. That is square root of that particular thing will be given 3. That is whatever present inside will give you 9. Right. So I will solve for 10x by x plus 1 is equals to 9. And when I solve this, the x is basically coming out as equal to 9. Now this is a very big limit. So what I observe is that when your x is lying between 2 by 3 to 9, then my whatever is present in the greatest integer is giving me the value equal to 2. Equal to 2, and similarly, and the rest is clear because you only have to go from 0 to 10. So whatever is present from 9 to 10, the greatest integer of it is definitely going to give you equal to 3. Simple, right? So therefore based on this I will try to plot the curve. So I will based on this I will try to plot the curve. So therefore Now the curve plotting is very easy in this case because it's a gradation function. So from the limit from 0 to 1 upon 9, this particular value is obviously going to be 0. From 1 upon 9 to 2 upon 3, this particular value is going to be equal to 1. And from 2 upon 3 to 9, this particular value is going to be equal to 2. And from 9 to 10, this particular value is going to be equal to 3. So this is my given way I can plot the required gradation function. Okay, so it's a very simple problem. It's a very simple problem. We just need to find the bound of the x, right? So in which value of x is equal to 1, 2, 3, and so on, right? So once you get this, the required area can be simply given out by the sum of these small these rectangles, right? So if you find it out, it is going to be equal to 2 by 3 minus 1 upon 9 plus 2 times of 9 minus 2 by 3 plus 3 times of 1. Okay, so if you solve it and you calculate it, you're going to get the accurate answer to this question as follows, which is going to be equals to 182 upon 9. Okay, now in the question it was given as I is equal to, so I is basically the definite integral, and definite integral is equal to the area under the curve in this particular case because everything is present above the x-axis, right? So therefore I will be equals to 182 by 9. Therefore you have to find out the value of 9 times of I, which is equals to 182. So 9 times of I will be equals to 182. Is this clear to all of you? Is this solution or the approach is clear to all of you? Please let me know in the live chat. Please let me know in the live chat. Is this clear to all of you? This is the most simplest way I can solve this question. Okay. Looking at the question, it might be very difficult, but if you try to, if you know that how to solve questions of greatest integer function, it's a very simplest question that was asked in the paper. Okay. So please try to see that how we have solved this question, and based on that, you can always solve this question on your own as well. Okay, just follow the approach. What is the approach I'm trying to figure it out? I'm trying to find it out that where is my greatest integer function equal to the integer value. So whenever you see greatest integer, try to equate the following in the function that is present in the greatest integer function equal to the integer, and from that you will find the bound of the x. Okay, so please try to do that in the following approach to get to the values of the bound of x. Okay, so once you get the bound of x, the greatest integer function or plotting the greatest integer function is the most simplest way you can do it, right? I hope this is clear to all of you. Okay, is this clear to all of you? Please let me know in the live chat. Please let me know in the live chat. Is this clear? Is this question clear to all of you? It's a very simple problem, right? Okay, so I hope this question is clear. So with this, I think uh, I have helped you out in solving some of the most important problems of JEE Advanced applications under the curve, right? Now there are certain few more questions also that you can always try by your own, right? Now one more thing I will also like to emphasize. Now sometimes the questions will be given in terms of a definite integral equations or integral equations, right? So let us say a question is given as a function whose domain is -1 to 2, and its codomain is 0 to infinity, is a continuous function. Okay, it is mentioned it is a continuous function. Okay, it is mentioned as a continuous function such that f of x is equals to f of 1 minus x. So that basically means it is symmetric about the line x equals to half, right? So f of x is equal to f of 1 minus x basically means symmetric about the line x equals to half, right? So it is saying that it is true for all values of x lying between -1 to 2. Okay. Now it is said that the region 1 is given as the integral -1 to 2 for the function x into f of x dx, and R2 denotes the area bounded by the curve y is equal to f of x equals to -1 and x equals to 2. Okay, then you have to find the relation between R1 and R2. Now these kinds of question might be little bit tricky in the beginning, but once you know the exact way to solve this question, or once you know the way to curve sketching or the things of curve sketching, or by simply use of the definite integral properties, you can solve this question very easily. Let me give you how you will solve this question. It's very simple. So if I look at the first region, so if I look at the first region over here, And if I apply the King's property, okay, that is from here, so 2 plus minus of 1 will become 1, right? So it will become 1 minus x, 1 minus x, and then f of 1 minus x. Now we know that f of 1 minus x is equals to nothing but f of x, right? So this is also my region. So therefore, if I add this region 1 and region 2, it is going to give me the result minus 1 to 2, and then this x and 1 minus x is going to cancel out. Ultimately, you're going to get f of x. So therefore, this is basically equals to this particular region only. So this is basically R2. So what you get over here is that 2 times of R1 is equals to R2. The most simplest problem that was asked in the JEE Advanced. Okay, so 2 times of R1 is equal to R2. Okay, so these kinds of problems must be also be there in the examination. When you look at the problem, it might look very difficult. It might look very difficult because looking at the problem over here, some might wonder, oh my goodness, there is the function definition is not given. How am I supposed to solve the question? Right? So you don't need to get the functional definition. You just need to apply your properties over here. So simply by applying the properties and solving the question, it is the most easy way over here, right? So therefore, when you solve question, please make sure that to understand how the properties is basically derived, because I have already discussed the derivation of each and every properties in detail. Okay, so if you haven't watched the lectures, please go back to the channel, please watch the previous lecture and then only come to watch this following lecture. Okay, because I have discussed all the properties in my previous classes. So, and I have explained each of every properties, and I have also taken one problems to illustrate how you will apply those particular properties over there, right? So with this particular thing, I think I have probably done the best in basically clearing or explaining you all these particular concepts of integrals. So with this, we are ready to start with our new chapter, that is differential equation, right? So in our next upcoming class, we're going to start as promised with this particular topic of differential equation. So we are going to start with the topic of differential equation, and along with that, we'll also keep on solving more and more questions from definite integrals and from area under the curve or applications of integration. So once we are done with differential equation, we will try to solve more and more questions. Okay. Hello, Singh. Okay, so please follow the channel. Okay, and please subscribe to the channel. Also, I'll hit the bell icon so that you don't miss out any upcoming notification. That is, whenever we are live, you get the notification on your device so that you have to watch the lecture live, right? Okay, so don't miss this particular opportunity. So keep on watching this channel, and also if you feel that you want to study in an online tuition mode, that is where you're studying one-on-one with me, then you can always opt for those one-on-one classes. So for that, please contact us on the given number that is given over here, right, in the live chat as well, and also in the description box of the channel. Okay, so please contact us on this number if you are feeling any difficulty in any of the concept. Also, you can go for the backlog clearing classes, okay, or backlog covering classes, where you basically get one particular chapter, whatever is your backlog, and you cover that particular chapter with us in a one-on-one online classes. Okay, so with this, I end the session over here. Thank you for your attention, and we hope to see you up in the live class of differential equation. So from the next class onwards, we're going to start with differential equation, and I wish you all the best. Keep on solving more and more problems. If you are having any difficulty, please post that up on the community as well as on the live comments over here, right? So